Hello everyone, uh, welcome to the fifth tutorial of this course. So in this tutorial I will be solving the assignment 5 from the course of 2021, and if you have any doubts regarding the lectures and all, you can ask me in the comment section, or you can unmute and ask. Okay, so let me share the screen. Okay, so I have shared the screen. If it is not visible to you, you can ask or you can write in the comment section. So in the problem 1, you are asked to find out the double integration of 2 plus x square plus y square, and the integration region is, so y is going from x to 2x and x is from 0 to 1. So the region looks like this. Let me draw the region. X y, so this is x is equal to 1, let's say, x equals to 0, and this is x, and this is 2x. So it is a region of type 1. You can call it phi 1x. Phi 1x equals to x and phi 2x equals to 2x. So you are asked to find out this integration in this region. So let's do the integration. So x is going from 0 to 1 and y is going from x to 2x. 2 plus x square y square dy dx. So first of all, we need to do the y integration. So in that case, integration, so it will look like this. So x 2x, 2 plus x square plus y square dy dx. So here if you do the y integration, it will be 2y plus x square y plus y cube by 3, and integration limit is from x to 2x times dx, 0 to 1, and the upper limit is, so it will be 4x, put the upper limit, plus 2x cube plus 8y cube by 3 minus the lower limit, that is 2x minus x cube minus x cube by 3 dx. It will be 2x minus plus x cube plus 7 by 3 x cube, sorry, it is y cube, yes, it is x cube, dx, which will become 0 to 1 2x plus 10 by 3 x cube dx. Now if you do the x integration, it will be 2 times x square by 2, which will be just x square, so I write it as x square, plus 10 by 3 times x to the power 4 by 4, and 2 to divide upper and lower half by 2, it will be, so it will be 5 by 6, so let's write it 5 by 6, 5 by 6 x to the power 4, and limit is from 0 to 1. Now if you put the upper limit, it will be 1 plus 5 by 6, and put the lower limit, it will be 0. So the answer is 7 by 6. Sorry, we add them, it will be 11 by 6. So the correct option is 11 by 6, the second one. Now in the second problem, we are asked to find out this integration, where we are asked to find out, we are asked to integrate in a region where y is varying from 0 to sin x and x is varying from 0 to pi. So the region looks like this. Let's call it pi 0. So the lower limit of y is 0, and the upper limit is sin x, and as x is varying from 0 to pi, it will look like this. Sorry, so you can call it pi 2x as sin x and pi 1x as 0. This is also a region of type 1. So in this region, we are asked to find out the integration of y. So let's do that. 0 to x is going from 0 to pi, y is going from 0 to sin x, y dy dx. So we will do the y integration first. So Gagan is asking, what do you mean by region of type 1? Actually, if you go through the lecture videos, it will be clear. It is clearly stated in the lecture videos. So in region of type 1 means where the y can be expressed in terms of this x. So this phi 1 x and phi 2 x. So with a single function, you can write this upper limit and lower limit of y as a function of x. So to pi y square by 2 from 0 to sin x dx. So it will be half sin square x dx from 0 to pi. Now let's divide it by half and multiply by 2. Then it will be 1 by 4 and 2 sin square x. It will be 1 minus cos of 2x dx. Then the integration of this will be x minus sine of 2x by 2. Integration limit is from 0 to pi. It will be 1 by 4. To put the upper limit, it will be pi minus sine of 2 pi by 2 minus 0 minus sine of 0 by 2. So both the sine of 2 pi and sine of 0, both of the value of them are 0. So in that case, the answer will be pi by 4. So the correct option is pi by 4. So in this third problem, you have to find out the volume of the fast octant section cut from the region inside the cylinder of x square plus y square equal to 9 by the planes y equals to 0, z equals to 0 and x equals to y. So first of all, let's look at this region. So you have to find out the volume. So the elementary volume dV, it is written by dx, dy, dz. So what you are asked to do is basically find out the integration of dx, dy, dz, and the integration limit that will come from this boundary conditions, this planes. So equation of this cylinder is x square plus z square equal to 9. It means in the xz plane it will look like a circle of radius 3. So this plane, this region is x square plus z square equals to 9. Now y equals to 0 means this plane is xz plane. This is the y equals to 0 plane. Z equals to 0 means this xy plane. This is the z equals to 0 plane, and x equals to y. So in this xy plane, if you draw x equals to y line, it will look like this. So x equals to y plane, so it will look like this. So it will intersect this cylinder like this. So basically you are asked to find out the volume of this region, you know, bounded, which is bounded by this y equals to 0 plane, this z equals to 0 plane, this x equals to y plane. So this, let's say this is your x equals to y plane, and this and the rest of this cylindrical region. So now if you write the limit, integration limit, dz. So first, if you are, let's say you are on this xy plane and you are looking at this z, so then z will go from 0 to this cylinder, to the surface of the cylinder, and this surface of the cylinder, the z value of this is z equals to root under 9 minus x square. So this is the equation of the surface of so any z point on the cylindrical surface. So in that case, z will go from 0 to this cylindrical surface, which is root under 9 minus x square. So we did the so after we did the z integration, now we are in the, let's say we are in the xy plane. So z integration is done. So in that case, if we vary the y, let's say we are trying to put the limit of y integration. So in that case, y will vary from 0 to x. So in the xy plane, the region, if we only look at the xy plane, the region will look like it will look like this. This is x. So y is varying from 0 to, this is phi 1 x equals to 0, and this is phi 2 x equals to x. So y is varying from 0 to x, and with that x will vary from 0 to 3, because this region, this cylindrical region, it's a cylinder of radius 3. So this is 3, x equals to 3. And this is y equals to x. So dx. So this will be the limit of integration. So now let's do the integration. 0 to 3, 0 to x. We first do the z integration. So it will be z. Limit is from 0 to root under 9 minus x square dy dx. 0 to 3, integration from 0 to x 9 minus x square dy dx. Now when you are doing the y integration, look here, there is no y dependent, so we can put it outside this y integration as a constant. 0 to 3 under 9 minus x square 0 to x dy dx. 0 to 3 under 9 minus x square y from 0 to x, which is basically x dx. Now if we consider 9 minus x square as, let's say, p, so in that case minus 2x dx equals to dp, or x dx equals to minus half dp. So the integration will be root under, so p to the power half minus half times dp, and integration limit will go from, so when x equals to 0, p equals to 3, p equals to 9, and when x equals to 3, p equals to 0. So integration limit will be from 9 to 0 minus half, and integration of p to the power half, it will be p to the power 3 by 2 by 3 by 2. Integration limit is from 9 to 0. So this half cancels, it will be minus 1 by 3, and we 0 to the power 3 by 2 minus 9 to the power 3 by 2. It will be minus 1 by 3 times minus 3 to the power 3, which is 27. So it will be 9. So the correct option will be option 9. So the volume of this region is 9 unit. Now the next problem, you have to find out the integration of cos of x square plus y square, and the region is given by this. So x square plus y square, it is less than equal to pi by 2 and x greater than 0. So then you are asked to find out this surface this integration, double integration of f of xy. So the hint is use the polar coordinate. It's because it is in terms of x square plus y square, and x square plus y square in polar coordinate, it is given by r square. It is given by r square. So first of all, let's look at the region. So the region is x square plus y square less than equal to pi by 2, or as x square plus y square equals to r square, you can write it like r square less than equal to pi by 2, or r less than equal to root under pi by 2. This length is root under pi by 2. So then this is the region. The x-axis is the y-axis. So we are asked to find out this integration on x greater than equal to 0. So we are in the right side of this y-axis. So in this region, r will be varying from this 0 to pi by 2, and if you convert it to the plane polar coordinate, along with this r, there will be a theta coordinate. So theta will be varying from minus pi by 2. So let's say this is a theta angle. So this is a theta angle, and theta will be varying from minus pi by 2. This is the minus pi by 2 to pi by 2. So we have to find out the integration of f of xy. F of xy is cos of x square plus y square dy dx, and now if we transfer it to the plane polar coordinate, this dy dx elementary area, it will be r dr d theta in the plane polar coordinate. So it will be cos of r square times r dr d theta, where r is varying from 0 to root under pi by 2, and theta is varying from minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2, 0 to root under pi by 2 cos of r square, and we can write it as half of d of r square d theta. So in that case, the integration will be minus pi by 2 to pi by 2 sine of r square by 2. Integration limit is from 0 to pi by 2 d theta minus pi by 2 to pi by 2. Sorry, the integration limit is from 0 to root under pi by 2. So if we put the upper limit, it will be sine of pi by 2 minus sine of 0 by 2, which is 0, times d theta. So now there is no theta dependence here, so we can put this constant outside. It will be half, because sine of pi by 2 is 1. So half integration from minus pi by 2 to pi by 2 d theta, which will be half theta from minus pi by 2 to pi by 2, which is half times pi equals to pi by 2. So the correct answer is pi by 2, third one. Now in this fifth problem, so you are asked to find out this integration of f of xy dx dy, where f of xy is e to the power minus x square minus y square. You can write it as e to the power minus x square minus y square equals to e to the power minus of x square plus y square. So in that case, it will be easy to consider the plane polar coordinate, and the integration region is bounded by x square plus y square equal to 1 and x square plus y square equals to 4. So if I write r square equal to x square plus y square, so in that case x square plus y square equals to 1, it implies r square equals to 1, and x square plus y square equals to 4, it implies r square equal to 4. Here it implies r equals to 1 and here it is r equals to 2. So our integration region is in the xy plane, and the integration region is so let's say this is the x square plus y square equal to 1, this circle of radius 1. Let's say this is a circle of radius 2 centered at the origin. So it is x square plus y square equals to 4. So this is 1, this radius is 1, 1, and this is 2. So we are asked to find out we are asked to integrate in this region. So it will be easier to if we consider the plane polar coordinate. So the integration is r e to the power minus x square plus y square times dx dy. So now if we transfer it to the plane polar coordinate, it will be to the power minus r square, and dx dy you can write it as r dr d theta. So now to put the integration limit, r is varying from 1 to 2. So from this this circle of radius 1 to this circle of radius 2. So r is varying from 1 to 2. So the lower limit of r is 1 and upper limit of r is 2. And this theta is varying from 0 to 2 pi, the entire region. So this is the theta, let's say. Theta is varying from 0 to 2 pi. Is 0 to 2 pi. So now if you do the integration, so we can do this phi integration separately because there is no phi dependence here. So you can just put this d phi separately, and we can do this integration separately. E power minus r square half d of r square. Now this integration is 2 pi theta integration, and this r integration is half e to the power minus r square by minus 1 from 1 to 2. So it will be pi times minus 1 times, so upper limit is e to the power minus 2 square, that is 4, minus lower limit is e to the power minus 1, which will be pi times e to the power minus 1 minus e to the power minus 4. So the correct answer is pi times e to the power minus 1 minus e to the power minus 4, the fourth one. Now problem 6, this is easy. So you have to find out this integration. So here 0 to 1, 0 to 1 minus y, 0 to 2 dx dz dy. So x is varying from 0 to 2, z is varying from 0 to 1 minus y, and y is varying from 0 to 1. So in that case 0 to 1, 0 to 1 minus y. If you do the x integration, it will be x with limit lower limit 0 and upper limit 2 times dz dy. So if you put the limit, it will be 2. You can put that 2 outside. So integration will be from 0 to 1, 0 to 1 minus y dz dy, 0 to 1. Now if you do the z integration, it will be z with lower limit 0, upper limit 1 minus y. So 2 integration from 0 to 1, and if you put the limit, it will be 1 minus y dy, which will be 2 times y minus y square by 2. If we put the limit, it will be 2 times 1 minus half, which is 2 times half, equals to 1. So the value of this integration will be 1. Problem 7 is also easy. So 0 to 1, x is varying from 0 to 1, y is varying from 0 to 2 minus x, z is varying from 0 to 2 minus x minus y, z dy dx. 0 to 1, 0 to 2 minus x. If you do the z integration, it will be z with upper limit this and lower limit 0. So the only upper limit will survive. So it will be 2 minus x minus y times dy dx. Now if you do the y integration, it will be 2y minus xy minus y square by 2 with lower limit 0 and upper limit 2 minus x dx. 0 to 1, if you put the limit, it will be 2 times 2 minus x times 2 minus, sorry, 2 minus x minus 2 minus x whole square by 2 dx. 0 to 1, if you simplify it, it will be 4 minus 2x minus 2x plus x square minus 4 by 4 plus x square minus 2x, sorry, minus 4x by 2 dx. So it will be 0 to 1, 4 minus 2x minus 2x plus x square minus 2 minus x square by 2 minus plus 2x dx. So it will be 0 to 1, 2 minus 2x minus, sorry, plus x square by 2 dx. Now to do the x integration, it will be 2x minus x square plus 1 by 6 x cube, limit from 0 to 1. The limit, it will be 2 minus 1 plus 1 by 6, which will be 1 plus 1 by 6 equals to 7 by 6. So the answer will be 7 by 6. Now problem 8, we have to find out the volume of tetrahedron in the first octant bounded by the coordinate planes. Coordinate planes means x equals to 0 plane, y equals to 0 plane, and z equals to 0 plane, and the plane passing through this 3 points. So basically, let's say this is 1 0 0, this is 1 0 0, this point is 0 2 0, x, y, and z, and this point is 0 0 3. So the plane that is passing through these 3 points, it will be this plane. So this is the plane. So this plane and this x equals to 0, y equals to 0, and z equals to 0. So the volume bounded by this region. So we are asked to find out the volume in this bounded by this region. So v is to integration. So this r is this region, and dx, dy, dz. So now let's find out this equation of the plane which is passing through this 1 0 0, 0 2 0, and 0 3 0 0 3 points. So if a plane is passing through points like x1, y1, z1, x2, y2, z2, and x3, y3, z3. So if a plane is passing through these 3 points, then the equation of this plane is given by, say, x minus x1, y, determinant of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1. This determinant equals to 0. This is the equation of a plane passing through these 3 points, x1, y1, z1, x2, y2, z2, and x3, y3, z3. So now the points are this. So we have these 3 points. So in that case, the equation of this plane will be determinant of x minus 1, y1 is 0, z. So now x2 is 0, y2 is 2, and z2 is 0. So in that case, it will be minus 1, 2, 0. Similarly, it will be minus 1, 0, 3. So 0. Now if you calculate the determinant, it will be x minus 1 times 6 minus y times minus 3 plus z times 2 equals to 0. So it will be 6x minus 6 plus 3y plus 2z equals to 0. This is the equation of the plane. And now if we want to write the z point as a function of xy, it will be z equals to 3 minus 3x minus 3y to y. The z point is any point, so if we put the value of xy, the z point will give any point on this on this plane, you know. So in that case, so now let's do this integration dz dy dx. So now z is varying from at any point xy. So let's say at any point xy, z is varying from 0 to point on the plane. So point on the plane is given by this equation. So z is varying from 0 to 3 minus 3x minus 3y to y. This is the z limit. Now if you look at the y limit, so you need to come to this plane. So y is varying from this 0, y is varying from this 0 to this line, you know. This equation of this line is given by, so this line is a line on the plane which is on z equals to 0. So if we put z equals to 0 in the equation of this plane, we will get the equation of this line. So if you put z equals to 0, it will be so if you put z equals to 0 here, it will be 6x minus 6 plus 3y equals to 0. So it will be, so equation of this line will be 6x minus 3 plus 6x minus 6, 6x minus 6 plus 3y equals to 0, or y equals to 2 minus 2x. This is the equation of this line. So after we do the z integration, then we need to find out how the y is varying. So y is varying from 0 to this line, and the equation of this line is y equals to 2 minus 2x. So y is varying from 0 to 2 minus 2x, and x is varying from 0 to 1. So this point is 1, x equals to 1. So x is varying from 0 to 1. So now if you do the integration, it will be 0 to 1, 0 to 2 minus 2x, z, and z is varying from 0 to 3 minus 3x minus 3 by 2y dy dx. It will be 0 to 1, 0 to 2 minus 2x. So if you put the z limit, it will be 3 minus 3x minus 3 by 2y integration dy dx, 0 to 1. So y integration will be 3y minus 3x square by 2, sorry, this is y integration. So it will be 3xy minus 3 by 4 y square. Limit is from 0 to 2 minus 2x dx. Equals to, so x is going from 0 to 1, and if you put the y limit, it will be 6 minus 6x minus 3x times 2 minus 2x minus 3 by 4 y square, which will be 4 minus 4 plus 4x square minus 4 8x dx. Integration from 0 to 1, so it will be 6 minus 6x, so it will be 6 minus 6x minus 6x plus 6x square minus 3 minus 3x square minus plus 6x dx. So to simplify it, it will be 3 minus 6x plus 3x square dx. And for the x integration, it will be 3x minus 3x square plus x cube, lower limit 0 and upper limit 1. And if you put the limit, it will be 3 minus 3 plus 1, which is equals to 1. So the answer of this problem 8 is 1. So now problem 9, the area of this region bounded by coordinate axis and the line x plus y equals to 2. So we are asked to find out the area. Area means integration of dx dy. Now let's find out the region. This x is y and this x equals to y, x plus y equals to 2 line is given by, so this is the x, this is the x plus y equals to 2 line. So we are asked to find out the area of this. So this is x equals to 2, this is y equals to 2. So in that case, the integration limit, so it's a dy dx, and y is varying from, so you can call it phi 1x equals to 0 and phi 2x. So y is varying from 0 to this line. So this line is 2 minus x. This is 2 minus x, from 0 to 2 minus x, and x is varying from 0 to 2. So it will be 0 to 2 y, from 0 to 2 minus x dx, which will be 0 to 2 minus x dx equals to 2x minus x square by 2, 0 to 2 equals to 4 minus 4 by 2 equals to 2. So the area of this region is 2. So one easy way to find out the area of this region is, it's a triangle of base 2 and height 2. So area will be half times base times height, also 2. So with this double integration, we got the same answer. And then last problem is, we are asked to find out the area of this region bounded by the curve y equals to e to the power x and the lines y equals to 0, x equals to 0 and x equals to ln2. So ln2 means log 2 base e. First of all, let's draw the area x y. X equals to 0 and let's say this is x equals to ln2. So y is varying from 0, so this is, you can call it, this is phi 1 x equals to 0, and the upper limit of y is e to the power x. So e to the power x means at x equals to 0 it is 1, and at x equals to ln2 which is 2, and it will vary like this. So you can call it phi 2x equals to e to the power x. So we are asked to find out the area of this region. So the area will be integration in this region dx dy. First we need to do the y integration. So phi 1x is 0 and phi 2x is e to the power x. So y is varying. So for a particular value of x, y is varying from 0 to e to the power x. 0 to e to the power x. And x is varying from 0 to ln2. 0 to ln2. 0 to ln2. If you do the y integration, it will be y into lower limit 0, upper limit to the power x dx. So 0 to ln2 to the power x dx. Now if you do the integration, it will be to the power x. Integration of to the power x is to the power x with upper limit ln2, lower limit 0. So then it will be e to the power ln2 minus e to the power 0, which is 2 minus e to the power 0 is 1. So 2 minus 1 equals to 1. So the area of this region is 1. So these were the 10 problems from assignment 5 of last year's course. So now Gagan is saying, can you solve question 10 from week 4 assignment? Okay, let me check assignment. So RT is given by root under 2t I hat root, root under root 2 plus root 2t j hat plus 1 minus t square k hat from point 001 to root 2 root 2 0. So that means, so from 001 to root 2 root 2 0, that means t is varying from 0 to t is varying from 0 to 1. So pt will be dr dt, so it will be root 2 I hat plus root 2 j hat minus 2t k hat two plus 4t square. So it will be under 4 plus 4t square equals to 2 times 1 plus t square. So ds is elementary length will be mod of v dt, and the entire length s will be integration ds, where t is varying from 0 to 1, which equals to mod of v dt, where t is varying from 0 to 1. So now mod of v is 2 times root under 1 plus t square dt. T is varying from 0 to 1, equals to now if you do this integration. So if you do this integration, I think you will get the answer. I don't remember the formula right now. Okay, let me check the formula. Yeah. So integration of this is 1 by 2 ln t plus root under 1 plus t square plus t times root under 1 plus t square, and integration limit is from 0 to 1. So if you put the limit, it will be ln mod of 1 plus root 2 plus root 2 minus ln 1 minus 0, and ln 1 is always 0, so it will be root 2 plus ln. It will be root 2 plus ln 1 plus root 2. I think this is the answer given also. Okay, so if you have any other questions, you can write in the comment section, or any doubts regarding the problems we solved today. Okay, if not, so that's all for today. You can leave one by one. I will end the meeting.